𝗏𝗏 has extensive experience in respect of environmental, mining, and energy regulatory considerations, and has worked on numerous projects and matters relating to electricity infrastructure development across several rounds of the South African Renewable Energy Independent Power Producer Procurement Program, and the development and implementation of energy projects within the C&I space. 𝗏𝗏 is also very active in respect of advising on decarbonisation strategies in achieving carbon neutrality targets and alternate clean and green fuel resources and innovation, climate change risks and litigation in respect of energy security, and has acted for lenders, borrowers, and off-takers in project finance transactions requiring the application of equator principles and IFC performance standards. Thank you for your time, 𝗏𝗏. Once we go over to you, I will introduce your topic. We will kick the evening off with 𝗍𝗂𝗪𝗔. 𝗍𝗂𝗪𝗔 has been fulfilling the role of Principal Engineer, Electrical and Automation at Assets, Strategies and Reliability, the AS&R team of Platinum within the Technical and Sustainability unit, and has been appointed as Head of Energy and Carbon Integration at Anglo American Platinum. Since joining Anglo American in 2012, 𝗍𝗂 has spent more than 6 years as Principal Electrical and Energy Engineer at Anglo American Coal, that has now since become Thungela, and more than 4 years at AS&R Platinum, with responsibilities for electrical and automation across the process and mining divisions. He started his career in 2002 as a graduate electrical engineer in the oil and gas refining industry, and has since worked across a range of mining and consulting companies and commodities in nuclear, diamonds, gold, and coal mining and processing sectors. He holds an MSc degree in engineering from the University of Pretoria and has professional registration with the Engineering Council of South Africa, ECSA, and is also certified energy manager and member of the South African Institute of Electrical Engineers. This evening, 𝗍𝗂 will speak on how to put together a high-level strategy or program for energy efficiency reduction in mining and processing, with a main step and pitfalls to look out for. I'm going to switch off my video so that 𝗍𝗂 has the required bandwidth, and please, 𝗍𝗂.
Thank you very much for that introduction, Maria. I'm just going to share my screen because I've got a small presentation that I would like to share. Just give me I've never used Zoom in this function. We normally use Teams in Anglo American. Just want to confirm if you can see my screen.
We can, thank you.
To put it into presentation mode. Okay, is that clear?
Yes, but you were on the correct screen. You're currently sharing your presenter screen.
And now?
Yes, that's perfect. Thank you so much.
Okay. Yeah, so good evening, everyone. It's not every Thursday that I've got an audience to talk about energy efficiency and greenhouse gas emissions in mining and processing, and how we're managing that in the PGM business. What I want to do tonight is to take the members through my thought processes and what I've done the last 12 months in terms of putting together a strategy in how we're going to approach the challenges that we as a company, Anglo American Platinum, are currently facing to achieve our goals to the 2030 targets, which is a 30% reduction in energy efficiency, as well as a 30% reduction in greenhouse gas emissions, which would make us one of the leaders in ESG as well as a sustainable and a responsible mining company. So when you talk about GHG, I think it's important to know where your power comes from and what that makeup of energy looks like when you use it. So I found this very informative graphic on LinkedIn a couple of months ago, And this is worldwide. So worldwide, the biggest driver of energy is still coal and natural gas, and hydroelectrical plus the 14% of renewable, which is wind, solar, and then some biothermal and smaller applications, makes up less than 30% of currently what's driving the energy across the world. And I do think that the role that natural gas and coal has played since the war in the Ukraine, those numbers have actually risen, and the use of solar energy or renewable energy in Europe has actually declined a bit. So if we think about where we're going in terms of greenhouse gas emissions and getting closer to reducing our carbon footprint for that 1.5% or 1.5 degree reduction in temperature, I think we're currently trending in the wrong direction. So what does that look like in terms of the South African market? Eskom is still dominated by 80% of coal. We've seen quite a big rush of solar coming on board in terms of what we're doing in rooftop, but the bigger IPP solar has actually slowed down quite a bit since the first 100 megawatt was put in. In fact, Eskom now recorded that the rooftop solar that has been installed by private companies as well as private households is now around the 4.8 gigawatts since the beginning of 2021. So at least in South Africa, I think we're trying to do the right thing and trying to get that redundancy in terms of where we get our energy from as clean as possible. We've got some small hydro in the country as well, and also making use of a lot of pump storage, and we know the OCGTs that runs on diesel. Those two in combined is around the 10 to 12% of what makes up the energy, and then we get about 1,800 megawatt from nuclear from Koeberg. So if you want to really understand what your carbon footprint looks like, you have to benchmark. And so what we did in 2021 is we benchmark ourselves in gigajoules per copper equivalent, gigajoule per copper equivalent ton, in terms of what does our energy efficiency look like. And you could see we are shots above what the rest of the world does in terms of gold, copper, nickel, lithium really low, iron ore also really low. And that is just due to the intensive energy usage in platinum, the smelting capacity that we need to treat our concentrate and to separate base metals from our PGMs. And also that pointed out to us that our focus needs to be in the concentrator, in the smelter environment, because that's where we use almost 80% of the energy in the company. So why do we want to do this? Well, we play a critical role in industry. We produce metals for infrastructure, for health, and I'm talking about PGMs, as well as for technological advances for future. We want to be a responsible miner, and we've set these goals for ourselves. So we want to say we are responsible. We want to say that we have a sustainable mining program that we're following. We want to target that GHG emissions. But also, if we can reduce our energy efficiency, it does drive down cost, because, like I said, the cheapest kilowatt or the cheapest part of the energy is the one that you haven't used. So part of the strategy is to also look at not only increasing our energy efficiency, but that same conversation comes also with improving our operating efficiencies, because the two are really linked together. And I think the message I want to bring to the group tonight is that we need to understand that energy actually is connected to everything. It's the common thread that connects all your processes together. And you shouldn't think of it in terms of a single process and try and solve the answer or the challenge in terms of a single process. You must look at your entire value process try and understand where your energy efficiency drive should come from. And I just, this afternoon while I was typing this, I thought about, you know, what we're currently doing. And I thought, let me just put that in an example of an open cast mine, that if your drilling and blasting is not done correctly, your rock break is incorrect, which means your loading of your truck is less efficient because there's more space on the truck, which means that you're going to use more diesel to move the same amount of tons because that truck is going to come back and be reloaded. And also, if the rock break is incorrect, you're going to spend more energy in crushing. And if the crushing is not correct, you're going to spend more energy in milling. And if the milling is not correct, you're going to spend more energy in milling, and you're going to lose recovery, and you're going to increase your mass pull because that affects your downstream concentrate process. So by not blasting correctly, you've actually influenced multiple processes down the line, which each of them in its own might have a small impact, but if you put all of that together, the energy intensity and the fuel that you've just wasted because your drilling pattern and your blasting calculations are incorrect can actually be quite significant. And that's the way that we're trying to approach this, that when approaching energy efficiency or carbon emissions reductions, is to not look at it in singularity, but rather to connect these processes together and find the common thread, because those are the things that small changes can actually make quite a significant and big change in your company. Sorry, and the one thing I did want to notice here is that, unfortunately, to be able to do that, you got to understand the process. You got to understand the fuel types and the energy types that's connected to each one of those processes, because that's the golden thread that will connect these processes together. So how do we do it? We've established a 6-pillar foundation, and I've tried to rely on some principles I've learned from industry, is to use mature and secure and widely available technologies. We don't want to do R&D. I don't think we've got time for that. And R&D is also extremely expensive. And in the current resource cycle that we're currently now, that is certainly not the time to be wasted on research and development. So we want to use something that's proven, something that's been done before, that we can adopt for our process. I also want to apply technologies that will have a meaningful impact on both energy cost and emissions. Because the two are connected together, it does make sometimes a strong business case, because sometimes you don't get the energy efficiency, but you do get the GHG emission, and vice versa. So it's really nice to have these two being connected, because that helps the business case in tough conditions. And we also want to deploy it quickly without, overcomplicating the solution. We do not have a lot of time. I think until the end of 2030, I've got 7 years to 6 years left to deliver this program, and in an environment that is not conducive to a lot of change. This can be quite challenging. So, what are the 6 pillars that I've set up? Is, you can't see some of these energies, so you gotta meter it, you gotta measure it to be able to understand what it looks like, and then integrate it into reporting so that you can start tracking it and track those KPIs almost on a daily, weekly basis. You got to understand how the energy is being used, and for that you have to measure and report and the types of energy, and then you have to audit and verify that you are actually measuring and reporting it accurately. And then the second step is to go into a little bit more of the theoretical side, which is the energy modeling and benchmarking. And the reason why this is important is it's nice to determine what best practice looks like and test it against some theories in industry. We've got multiple types of concentrators in the world, and it's very nice to benchmark it against other companies' PGM concentrators to know, are we actually on the right path? What are they doing better than us? And can we learn from each other? It's also benchmarking and some of the modeling also shows to you where you're wasting energy. And it's sometimes very hidden, and you really need to go dig for that. And then also, it helps us to right-size the process. So sometimes, you know, our plants are too big, and they are more in the idling mode in running between 25 and 50% of capacity, but your base load is still at 100%. And in that way, you're actually wasting a lot of energy. And then from there, we then develop our energy efficiency programs and embed that into operational efficiency, and that helps plant stability. I think the last year, the one thing that we have proven is that a stable plant is an efficient plant. Unfortunately, that also comes with a little bit of a trade-off in terms of right-sizing your plant, because you might need to buffer a little bit more to enable that plant to run stable. So there's a bit of a trade-off that each one of these programs will need to go through. And then prioritization and how do we implement some of these initiatives or projects. You've got some of those short-term gains, and then also I've definitely have some long-term projects which are a little bit more capital intensive. And each one of these projects does have to have a positive business case. Like I say, if it's not energy efficient, it has to be positive in the GHG emission reduction, or vice versa. Otherwise, the accountants do give us a bit of a hard time to get the money for it. Some of the simple advances that we've done is right sizing and using high efficiency motors and VSDs on as many applications as possible, and also introducing some more control into our advanced process control, so that we make sure that we actually use the technology that we employ. I think a lot of the time we invest and we employ technology, and then, you know, we don't really use it for the design or the capability that it was installed for. I think it's also imperative in our business that we make use of heat recovery systems and try and optimize heat exchangers, because there's a lot of wastage of heat that is unrecovered currently in our business, and I'm looking into that with a serious eye at the moment. Electrification of fleets, and that goes very much in line with the next point I wanted to raise, which is fuel changes. I think what we need to do is to look more at the direct application and the use of energy, and limit conversions, because every time that you limit a conversion, you take efficiency, a part of efficiency, out of the equation, and you have a more direct conversion from either heat to energy or energy to heat, and that's very important. And then really, really important is training and employee engagement. I think people and our culture is the biggest key and the success of this program. I think one thing that we're working on is embedding energy efficiency and energy efficiency programs into our process rhythm and into our operating model. And a lot of energy efficiency lies within how disciplined we are in terms of switching things off when it's not needed. And to be able to do that, you got to take your people with you on this journey. Everyone on site has to be an energy manager, and everyone has to own this program, because if we don't, then I can employ the best technology, but unfortunately it will fail, because technology is so much dependent on the person that uses it. And if we don't use it as efficient as possible, then the technology will fail at the end of the day. And then continuous improvement is the last piece. Once you've employed, you have to go back and measure. You have to analyze and see how you can improve the process, even though it's brand new. So this is a very busy slide, but this is my mind map I used to put together my strategy. And I used this standardization. For me, was to create a standard in terms of how do we want our data to look, how do we want to report it, and what are the points and what are the fuel types that we want to measure. And that is from there on, we created the systems in terms of data traceability and the management of the data, so that if if we want to use the data for tax or for any other measure, we know that the data is verified and certified. And that's really important, because if your data cannot be trusted, you're setting yourself up for a really difficult journey. From the data modeling, to ensure that we benchmark, we can scenario plan, we can forecast what it would look like accurately. We also use that to continuously remodel as we make changes, because the one thing with a plan is, unfortunately, there's always another plan. Out of the modeling and the systems, which the systems also has a huge auditing, we then created a project profile where we then do pre-feasibility and feasibility studies and run it into a capital program. I'll talk a little bit about the roadmaps a little bit later. And then from there on, you'll see that the carbon downward drivers are really the initiatives coming out of the projects and the modeling that we can use to now start focusing on operational energy management. And that's daily modeling, daily reporting, operational control given to the operators. They need to understand what their energy looks like and how to control it. And in parallel with everything that I've said there, we immediately started a program to pursue alternative energy sources. I think it's been well documented within Anglo American and within the South African media, our relationship with EDFR and 𝗣𝗶𝘁𝗆, where we as a company are going to procure between 500 and 600 megawatt of solar and wind. So photovoltaic is a big driver for us in terms of GHG reduction. Unfortunately, that does not drive down energy efficiency. You still need to change the way that you operate to get those wins. Fuel switching in terms of the hydrogen economy, and I'm excited to listen to what my co-hosts are going to say about that. And then we're also focusing a lot on mini grids on site to help our own housing and our own operations in terms of solar, and that is to really cater for power interruptions and what all of us has gone through in terms of load shedding. Carbon capture is very expensive. I think it's something for the future. We're going to wait a bit until that maybe that technology may be mature a little bit more. And then the C&I automation and digitalization in terms of our APCs, that really now is interconnected with our operational energy management. And that will be a big focus for me and my team in the next 24 to 36 months. So it's important to build a roadmap. What I'm showing here is just a mock-up of in terms of where we were in 2016 and where we want to go in 2030. But if you do not have a plan and a roadmap, I think you're on a road to failure. You need to know every month, every week where you are. The data, like I said earlier, needs to be really, really accurate and needs to be trustworthy. And stick to your plan. One of the biggest challenges that we're facing at the moment is the employment of technology. We are in a really difficult place with our resource cycle. And because this is a very big strategic plan for Anglo American Platinum, some of these projects are really difficult to get through because there is a little bit of capital involved. So I've had to change the way that my program run between now and 2026, where we're going to focus more on operational energy management and less on projects and deployment of capital. So in terms of one of the pitfalls, I think you got to always be aware of the market and what the market is doing and drive and change your program to be market relatable. So I think both in terms of energy efficiency and GHG emissions, we will most probably achieve the GHG emissions earlier with 𝗍𝗏𝗄𝗏 coming on board in 2026. But the energy efficiency drive towards 2030 going to be a real challenge, but it's something I'm looking forward to. I've got a very strong team behind me. I've got some very clever thinkers and clever people that is coming up with some really magnificent technologies and the way of thinking, and we're really looking forward to it. And yeah, happy to take any questions. Thank you.
Excellent. Thank you so much, Jaco. I just have to say, I love a couple of things that you said that's stuck with me, and definitely everyone must be part of the program and have ownership of the program, because that small incremental changes can change into large steps, either positive or negative. So it's always great when everyone takes ownership, and that makes just the small steps easier. And also that one has to understand the complete process from the beginning right through to the product that you bring to the table. Let's see if we do have any questions for Jaco at this point. If you are shy and you don't want to come off mute or put your, there we go, Pity, you can please type it in the chat as well, or you can send a direct one to me as well. So Pity has her hand up. Pity, please come off mute, switch on your camera, and we can take your call.
Good evening, everyone. Very lovely presentation, Jaco. Thank you for the information share. I think what interests me is how you've brought your people along with you on the journey. What kind of training did you have to do? And in terms of compliance, what are you seeing with the culture shift?
Yeah, thanks. So I think we still have quite a bit of a long way to go in terms of awareness, in terms of making making everyone understand and making their energy metrics visible on all our operations. It's something that we're working hard on at the moment in terms of that daily KPI dashboard reporting, so that even your shaft worker is made aware of where they are with the energy usage of the day. Is it red, or is it amber, or is it green? There's quite a bit of development and work that we still need to do in that space. I don't think that we're there yet, but on the main drivers, we have elevated the reporting and the use of energy now onto our OpsCo dashboard, which was never there before. So what has happened is we've written the performance of energy and how we use energy into the GM's KPIs, and that is significantly changed how we operate. But how we get that down to the floor level, that visibility does not exist yet, and that's something that I'm working hard on to get right, even before the end of this year.
Just to follow up, Jaco, when you say you're working hard on it, what kind of training programs do you have in place? Do you maybe train the operators on energy efficient mining? Do they maybe have to know? Do they know how you measure energy, and if they do save energy, how much savings they've done over a period? How do you communicate that?
So I'm going to give you one example of a program that we rolled out. So we did an awareness program at one of our deep level mines in terms of making people aware when it's, and this is very simple, and we did a trial for about 6 months, making people aware of when it's peak time electricity and when it's non-peak time electricity. And what we then did is we rolled out a program where a winder operator, if it's within peak time, does not have to wind according to cycle, but according to winder load. And what we did is we trained him to understand the differences between peak cost and standard cost, and we actually had a live dashboard on his on his computer to tell him that if he wines now, this is the cost of that wine. Well, or if he waited 30 minutes later, that would be the cost of the wine. So make him just not energy conscious, but cost conscious. And we could bring our peaks over peak winding and the increase of winding over peak times, we reduce it by over 50%. And it's those simple processes. And maybe I used the word training incorrectly, but it's more energy awareness training that we're doing. I don't think I want to roll out the theory of energy for everyone, but it's more being energy conscious and energy aware. That is the conversation that you need to have.
Yeah. Thank you, Jaco, because I love the fact that you touched on data and data governance, because that's my little love affair that I have. But what I have found that is along the value chain of a process, if a person understands what they're doing and the impact either upstream or downstream, they tend to want to take more responsibility for what they are doing, because they do then understand the impact that they can have. Yeah,
fully. And it's important. It's really important to incorporate those KPIs into each other, because then you make it more visible. And I've found exactly the same thing. You know, the more knowledge you give to people, the more interested they are in it, and then it just becomes such a, you know, it's a self-feeding program at the end of the day.
Yes.
And it's actually very nice and it gives a bit of satisfaction to see how people take hold of that.
No, it's that empowerment that happens with it. I do have a question for you regarding your data and your audit and measure and so forth. Did you have any part of this program where you would have a standardization of the definitions of when you look at how you report, so that you ensure that the whole group of Platinum, Anglo Plat, uses the same consistent terminology?
So correct. So very much based on field type, the amount of reporting and how we will actually access the data. If you think about anything that's fluid or anything that's driven electrically, is quite easy to measure, but things that is invoiced like gas or things that invoiced as coal, it becomes really tricky. So that measurement point might be weekly or monthly, but so we've written a standard and we've based it on ISO 15000. So we've used the international standard to guide us in terms of how we measure and make the measurable immediately compliant to what if we want to use it secondary, because you don't want to go back and need to re-audit just to ensure that your data is correct. So yeah, so it's very much dependent on the energy type at the moment, but we've used the ISO standard to guide us in that sense.
Excellent, thank you so much. If we don't have any more questions or comments for Jaco, I will now give over to, thank you so much, Jaco. It was really interesting for me, because I love processes and I love data. So it was really interesting. Thank you for sharing. I'm quite sure that if we have any questions later, we can pop them over to you and maybe continue the discussion.
Thank you. Okay. Maria, as I said, unfortunately, I've got to dial off for another call. I would really love to hear what Mary-Ann is saying in terms of the hydrogen economy. So if somebody can just send me the link for the recording so that I can listen to that later tonight, please.
Perfect. So what will happen is we have the recording, and we will only be releasing it on the platform in 2 or 3 days. But once that releases there, we'll make sure that it finds its way to your inbox. Is that fine?
Thank you. I would appreciate that. Thank you.
Excellent. And once again, thank you so much for your input and your time. So now I'm going to give over to Marga-Ann. She'll be discussing the role of mining in the hydrogen economy value chain, opportunities for decarbonization and commercial benefit. Thank you so much. Once again, I'm just going to drop off my video so that you have enough bandwidth available.
Thanks, Maria. And good evening all. And I'd just like to thank the WiMSA team for inviting me to speak on quite an important theme. And I feel like these discussions are really important. I've certainly have a number of takeaways from 𝗣𝗂𝗄's presentation, and it's always so nice to see what's happening on the ground, sort of compared to us lawyers who are stuck in our policies and laws, and have ideas, but they might not necessarily play out on the ground in reality. And it's about having these discussions to ensure that actually there is an alignment between what's happening in practice and what the laws provide for. So just on that note, I would just like to sorry, has my screen been lost?
No, we're seeing your main screen, which is the actual PowerPoint layout. It's not in presentation.
Okay. Sorry.
No worries. No worries.
I will get there. I'm not sure what I've done wrong. How do let me try and restart.
Yeah.
The process.
Okay, now you're sharing. You must just pop to the other screen. So at the top, you'll see you have the option of another screen, display settings. No, a bit more to your left. At the top, up, second one over.
Sorry, it's strange because the Zoom dash is blocking the. Oh, there we go. Okay, display setting. Thank you.
Okay, so there you should be able to see your swap. There we go. Let's see if it does that. I'm working on the assumption that you have two screens.
Yes, I do, and I think I've now got it right.
No, we're seeing your crypt notes.
So,
So when you do your share screen, just make sure that you have the correct one selected.
yeah, hopefully 3 times a charm. Here we go.
So where you started off, so we see your PowerPoint presentation as a layout, what you're still working on. So what I would suggest, if I may, if you stop sharing your screen and you open everything up like you would as if you're presenting, then it's probably going to cover the Zoom, and then you just bring the Zoom to the front, and then you can select the correct screen to share. That normally works for me.
One more trick. I'm hoping
Success.
Okay.
Yes,
Thank
there
you.
we go.
Excellent. Our time with
No,
I'm
no
clearly not
problem.
proficient in.
Excellent. There we go. Thank you.
Thank you again. So I'll just be unpacking at quite a high level because it's quite an intense subject, and it has so many aspects to it. And it's quite easy to go down a few rabbit holes in trying to unpack it. So I really will try my best, again, as a lawyer, to be succinct in really just touching on what we certainly at CDH are observing in terms of the development or the potential of the development of a hydrogen economy in South Africa and Africa, and the role that our extractive industry certainly will play once this hydrogen economy comes into being. And just to also just sort of touch on, again, the opportunities to the mining sector in adopting hydrogen in whichever form it will be, either as a fuel, an energy carrier, or in the development of specific products from that hydrogen resource as an input to processing, and how that would contribute certainly to the decarbonization of actual mining activities. And then again, the opportunities available to the mining sector in being quite an active player in the hydrogen economy, not so much just an off-taker, but itself one potentially as a producer, but certainly the role that it plays more in sort of the upstream portion of the value chain. But I will unpack that as I move along the presentation. So again, I think it's common knowledge or common cause, as we say in the court, that we're facing what really is a climate change crisis globally. And I think it's that global element to it that is maybe not fully appreciated. And although Africa really contributes, I think the current percentage is about 4% of the global greenhouse gas emissions, we still have quite a material role in contributing towards reducing our global carbon footprint. And that role is quite vast. One, in terms of the renewable resources that Africa has been blessed with, and the role that we can play specifically in the hydrogen production space. Again, in offsetting, off-takers in more northern hemisphere, and specifically Europe and Asia, in offsetting their greenhouse gas emissions and contributing to their targets, which at the moment are with more industrialized countries and developed countries being the greatest contributors to the global carbon footprint. So, I mean, obviously, off that theme, there are, I suppose, a lot of strategies and ideas and plans around how to reach these various targets, whether they be international obligations, such as South Africa's commitments in terms of the Paris Agreement, and our specific nationally determined contribution, or whether it is industry targets or individual company targets to reach carbon neutrality. I know certainly in advising a number of clients in the mining space, a lot of efforts to achieve certain targets by 2030, which is encouraging, but I think given that we don't have much time until we get to 2030, Jaco mentioned we have 6 years, and I think we should look at it as being even less than that. There's a lot of work to get to that, and then of course the eventual sort of real material goal of net zero by 2050. In sort of trying to figure out how to go about it, achieving these targets, there needs to be, and obviously, again, as Jaco touched on, is an appreciation for where these emissions are coming from, and one, obviously, we note them as scope emissions. So within those various scopes, whether it's scope 1 being direct contributory emissions by the industry, scope 2 being the more indirect emissions, such as are reliant at the moment on Eskom generated coal electricity, as an example. And then the difficult aspect of scope 3, which really extends both up and down, certainly the mining sector's own value chain, you know, one in terms of the use of its, you know, the minerals that have been extracted and processed, and how those minerals are used and what impact that might have. And I think our miners in the coal space play a specific and significant role in that regard. So it really is about one, appreciating what those scopes of emissions are, where they fit in, and how to try as best as possible to almost extend one's decarbonization strategy across that board. And again, I think hydrogen, which I'll try and pack a bit more, presents that opportunity. And that's just because hydrogen can be utilized in so many ways, and presents so many decarbonization opportunities, that its use and integration into even one industry's own emission value chain would present quite significant decarbonization successes. So again, there's been an appreciation by government, certainly, and as I move on, I'll touch on the policies around that. As to the opportunity, that South Africa certainly presents, just both, you know, in terms of a global impact, but also at a very local level, in becoming a key player in the hydrogen space, mainly in the production of hydrogen. And that's, I think, there's a lot of excitement around it, certainly within various departments, whether it's the DTI or the DMRE or the 𝗣𝗶𝘁𝘆, Department of Environmental Affairs, as to how, again, hydrogen can contribute in so many aspects. One, as a potential new commodity that we can offer for export. Two, as a local solution to our own decarbonization needs, and sort of the greenification, if I can put it, of the various sectors in South Africa. And again, sort of the sustainability potential that it has, with the actual use of hydrogen having a very, very low environmental impacts, again, depending on how that hydrogen is manufactured, but also to the social and economic development that hydrogen presents. So there's a lot of excitement and enthusiasm of hydrogen potentially playing this role. I think we have some way to go, but we've certainly seen an uptick in trying to really leverage and get this hydrogen economy going and becoming a reality in South Africa. And I'll perhaps just pause there and just share with those present. I attended a recent hydrogen conference, which sort of was the first one was held in 2022, and this one, although set up by a different developer, had very much the same attendees. Although the mining sector was somewhat lacking in terms of presence, at no fault of the mining industry, but it would have been really great to have more of a presence in those discussions that were had at that conference. Again, because it spoke to, one, the decarbonization benefits that are very much available through hydrogen use, as well as commercial benefits with the possibility of industries very much partnering together to develop very innovative projects. And that sort of leads me to my second last bullet point on this slide, around the real opportunity that exists for integrated projects. The hydrogen itself is a value chain in of itself. There is the production side of it, the actual distribution side of it, and then the use. And just in the production side of it alone, there are so many segments. And again, if we look at the fact that, especially if you're wanting to produce green hydrogen, which will be produced with renewable energy as the electricity input, and then obviously that electricity is fed into the electrolyzer. It's that material nature of that electrolyzer that is becoming more and more apparent, especially the role of the mining and certainly the PGM mines will play in, because PGMs are such a material component to those electrolyzers. So it is an absolute opportunity just sort of on the electrolyzer production arm. And then, of course, leading on to effectively the mining industry becoming a potential off-taker of that hydrogen that is produced. So there are a lot of players. There's the value chain can be simplified almost down to sort of 3 categories, but within those categories, there's such extensive further arms that branch off, and with additional role players there, and sort of just about coordinating, having a clear vision amongst very different industries, but industries that I think have sort of the common goal and commitment towards decarbonizing their processes, and also just in working together, overcoming sort of any risks or challenges in terms of the sharing of learnings. So, for example, the renewable energy sector have been in South Africa for a good number of years, very well established. They can share so many of their learnings as being a segment within sort of that production phase. So there's I think still a lot of collaboration that still needs to happen, and it would be excellent to see the mining industry playing a bigger role in those discussions, because I think the mining industry plays itself quite a significant role, both in terms of its input from a minerals perspective and as a potential off-taker in appreciating the opportunity that hydrogen presents to achieve decarbonization. I've just made a last point there about, and it might actually be more appropriate when I unpack the policy considerations, but these potential hydrogen projects, of which there are already a few that are earmarked for development, they've actually been identified as strategic integrated projects by Infrastructure South Africa, and have been declared or have been given this sort of specific status, which certainly allows for the streamlining of the development of these projects. A great example is, sort of for example, on the permitting, the environmental permitting side, whereas we have sort of set prescribed timeframes for applying and acquiring environmental authorizations or water use licenses. The benefit that a SIP had is that those timeframes are expedited, which again, it allows for there to be momentum in developing and actually implementing these projects without, inordinate delays, just on the basis of permitting. But that's just sort of a point that I wanted to throw in there about there is enabling legislation and policy that actually can make the development of the hydrogen economy a reality. So on that point of enabling policy, we do have a number of policies, one in draft form, but a number of policies that very much speak to the establishment of this hydrogen economy. The one key policy is our Hydrogen Society Roadmap for South Africa. That was published in 2021. It really sets the tone of what is to be achieved in implementing and developing a hydrogen society, who all the players are, where hydrogen will be focused in terms of specific sectors, with mining being a focus area within the Hydrogen Society Roadmap. Again, both as a player in the production side and a player in the offtake side. So it really sets a couple of targets and sort of guidelines and goals that we are already seeing, especially the Department of, or the DTI, Department of Trade and Technology and Innovation, apologies, already quite active in trying to tick off the various goals, such as the establishment of the proposed hydrogen valley, which I will use as a case, as a sort of as an example of what the potential is. Sort of launching from that, we now have South Africa's Just Energy Transition, which is really quite an important document. It perhaps is the one that really sets the tone for the implementation and for the development of additional policies around how do we transition to a less carbon intense, more economy and society. And in that Just Energy Transition plan, what's quite important to note is that 4 sectors have specifically been identified as being the ones that will be initially and directly impacted. And the item 1 of that is the coal value chain. And within that coal value chain sits difficult to abate industries such as mining, and I think the other example was cement manufacturing and steel manufacturing. But it's evident that our just transition and our transition away from fossil fuels, and particularly coal, will have a direct impact, especially given our reliance on coal as our current baseload electricity source. About 85% of our electricity is generated from coal, and the mining industry's reliance on that electricity need, being a high electricity consumer industry-wide. So how that transition plays out will have a direct impact, and that sort of requires the mining industry to take proactive measures to itself ensure that it is not impacted negatively in that transition. And that's the whole point of the transition, is to mitigate any adverse impacts as we head towards a decarbonized society. But it does also mean that we can't really just sit and wait, as that transition rolls out. It does actually require industry to take quite an active and play an active role. And we're already seeing that with a number of mining houses going the embedded generation route, and either partnering or themselves establishing subsidiaries who will develop and generate renewable energy, with the mines being the main off-takers of that renewable energy, therefore alleviating those mines' reliance on Eskom, and obviously contributing towards the carbon neutrality goals. So we are already seeing those initiatives in the mining space. We also have the green hydrogen commercialization strategy, sort of has 5 pillars of focus areas, but again, is really very much focusing on hydrogen in different instances. One from an export perspective, so our global reach, and the role that South Africa can play can play as a key exporter of hydrogen in whatever form it will be, as well as the development of a domestic market. And again, I feel that the mining industry would be a key player in establishing a domestic market for hydrogen, again, as an off-taker, and two, certainly as a role player in the production of hydrogen. What I think, again, and I speak to sort of the learnings and takeaways from the conference that I attended, was that there's a little bit of a gray area around specific legislation that will facilitate this hydrogen economy. What we're seeing in Namibia is that Namibia, again, already making massive strides in the hydrogen space. They have specifically developed a piece of legislation that speak to hydrogen. We have a number of pieces of legislation that hydrogen could potentially fit into. Certainly, from an environmental law perspective, we have sufficient provisions that that would facilitate certainly permitting of hydrogen projects. I think the gap lies in what hydrogen will serve as, depending on its form, whether it would fall under our existing Gas Act, whether it would trigger anything in terms of our Pipelines Act. So there are a couple of gaps at the moment, but hopefully those will be identified and plugged once we really start seeing the feasibility of projects and then the actual drive towards implementation of those projects. So there is still a bit of work on the development of legislation, but again, it's a question about whether we have sufficient legislation or whether we do need to bolster, specific legislation that will facilitate hydrogen specifically as a commodity. I'd just like to spend a little bit of time on this rather convoluted value chain. It looks quite simple on the screen with it just being sort of 3 items, but again, as mentioned, each of these items are in of themselves, maybe rather be looking at a macro, the macro value chain, but within these areas of the value chain, there are so many levels that one can get quite carried away, and it's again an opportunity to assess these specific value chain areas to see where the mining industry fits in, and what opportunity the mining industry can derive at each level of this value chain. So upstream, as mentioned, is relates to the production of hydrogen. Again, I think globally about 94% of hydrogen that is produced from a fossil fuel electricity input. So, and that is referred to as gray hydrogen. It still has a fossil fuel base, and of course the sort of the golden standard of hydrogen production would be the production of green hydrogen, which would be linked to a renewable energy electricity source. And it's that production sequence that is actually that is really fascinating, and in itself presents so much opportunity to the mining industry, whether it's the establishment of a renewable energy facility, whether it be wind or solar, or even hydro or biomass. Again, the mining industry has quite a significant role to play there. One, in terms of themselves utilizing their proposed renewable energy projects. If there's spare capacity, how that potential spare capacity can be used as an input into an electrolyzer, whether it be on a really very small scale or own hydrogen production potential. So with a lot of mines attempting to go off grid, reduce the reliance on Eskom and coal generated electricity to more renewable self-sustaining, really, off-grid solutions, specifically renewable energy generated electricity. Those projects shouldn't just be viewed as serving as an electricity source and security, although I think at the moment we certainly need to appreciate that we are facing an energy or electricity crisis in the country, and therefore our need for energy security is perhaps top of mind, with hydrogen being coming subsequent. But there is again the opportunity to consider how those proposed projects, or even projects that are already in implementation stage, could contribute towards the production of green hydrogen. Midstream, also quite self-explanatory, but a very complicated area within this value chain around the storage and transportation of hydrogen, simply because hydrogen itself, and I'm no chemist, but from what I understand, is quite a volatile element, difficult to compress, highly explosive. So again, the development of that storage capacity, is it going to be a pipeline? Are we going to move hydrogen that is produced by trucks that themselves are hydrogen fuel cell powered? But again, quite a complicated area in that midstream one. And then downstream, really, where we want to develop this hydrogen market, and where the mining space again plays a significant role as a potential off-taker, with the appreciation of what hydrogen presents to decarbonization needs. And again, hydrogen off-take could be again in various forms, whether it will be in a hydrogen fuel cell like we're already seeing at the 𝗍𝗶𝘁𝗍𝗶𝗀 mine with the Runner project, which is really incredible to see it in reality, or whether eventually hydrogen will actually serve as an energy input for the generation of electricity itself, which is quite circular, but a prospect that is appreciated. So this incredible value chain. There are so many opportunities within each stream, with the mining industry again playing quite an important role, I feel, in each of these. And it's just about unpacking these and exploring them and getting quite a refined view of where the opportunities lie, because I think at the moment it's a little bit all over the place and up in the air. And again, let's take away from the talk amongst industry. Maria, please tell me if I'm perhaps going a bit over time.
Yes,
I think I might be talking a bit. Apologies.
Yes, you are going a bit over time, and we still need to fit in Patty. So if you can take a minute to wrap up, and then we can have like 2 minutes for questions, and that's it.
Sure. Again, there are a couple of challenges, and I think that's what we are picking up in terms of exploring the potential of this sector. They are also quite explanatory. Just to give an example around cost, we were looking at about like, if oil is $100 to the barrel, as a simple example, hydrogen would be $6,000 to the barrel. So it's quite a significant cost at the moment, but of course that will come with economies of scale as this industry develops itself. Limited infrastructure, again, that comes down to that midstream difficulty of, are we actually going to distribute this highly volatile element, which, despite its high potential, the energy losses along the way in that conversion process, somewhat more technical, but it is being taken notice of. And also, I think a big one, and this is one that will affect the mining industry specifically, is the lack of differentiation. At this point in time, there's really no real definition around what constitutes green hydrogen. Does that green hydrogen definition stop at the point of production? Or if you're going to be distributing it via diesel-powered trucks, or carbon-intense transportation means, does that sort of take away from the actual decarbonization benefit that the product presents? So I think that just emphasizes the need for the decarbonization of that entire value chain, so from production to distribution to offtake. But hopefully we'll be able to overcome these challenges. Again, I won't touch on this particular example, but it is one that, and this is the proposed our proposed hydrogen valley, of which there are a number, but this is one that is being focused on at the moment. That will be connecting a number of provinces, each serving a role in this hydrogen economy in different forms. But I'll pause there for any questions and just conscious of time. Thank you.
Okay. Thank you so much, Margo. So what I hear is that there's a lot of potential for it, but we're still looking at policy. And it's in early days, and that hydrogen fuel is kind of like me. It's got high potential, but it's not, it's rather volatile and unstable. So we do have a question in the chat. Is there exponential growth in the interest towards the hydrogen economy as compared to when hydrogen technologies were initially introduced into the mining sector? Have you found that with your clients that there's an uptake in that more so recently?
Yes, absolutely. If anything were to go back from the takeaways from that conference, there are projects that are ready to go. There are partnerships that need to be made. So there's definitely a push to get this off the ground. I think there's there's becoming more frustration because it just feels like there's a delay in getting something off the ground that's feasible and that's tangible. But yeah, hopefully we can direct that frustration into a solution. But certainly there is exponential growth. I think it's a good description.
Okay, excellent. Perhaps we should start looking at hydrogen as a static fuel cell instead of trying to fit it into a model where you have to move it around. So instead of having vehicles powered by hydrogen, it might be more feasible to look at it as a stationary battery or something that would then feed stock to the plant or industry. I don't know. I'm not a chemist either. So thank you so much for your time, Margo. Unfortunately, we had to cut you short there. It would have been interesting to hear a bit more of what you had to say. If you have any additional questions for Margo, please drop them in the chat or send them on to us and we can pick the conversation up on our socials after the time. Well, 𝗣𝗶𝘁𝘆 was not in the room when I did the introduction, so I did not do her introduction. So I'm going to quickly do 𝗣𝗶𝘁's bio. 𝗣𝗶𝘁𝘆 was born and bred in Limpopo, Bugersfort area, where 𝗣𝗶𝘁 was raised in a mining town. She's currently a production section manager at Thungela 𝗍𝗄𝗄 navigation pit. She's a mining engineer graduate from the University of Pretoria, and she holds an MBA from the University of South Wales in the UK. She serves as council member on the South African Colliery Managers Association, SACMA, and is technical lead for WiMSA. She's passionate about mining and empowering women in the mining industry. And it's also thanks to 𝗶𝗁 that we have this wonderful session organized today. And 𝗶𝗁 will have a discussion on the energy efficient solutions for mining and operations. So 𝗶𝗁, I'm going off camera to increase your bandwidth.
Thanks, Maria, and thanks for the lovely introduction. Please let me know if you can see my screen.
We see your screen, we see the slide deck. It's not in presenter mode.
It's not in presenter mode yet.
No.
And
there we go. Excellent. 100%.
Great. Thank you so much. I'll try to be quick. I am cognizant of time, so I'll quickly run through it. And I think the previous presenters probably touched on most of my presentation, so it's an easy job for me tonight. Yeah, so I'm going to take us through quickly energy efficient solutions in the mining industry. And I think Jaco touched on quite a number of the solutions that I'll be looking at tonight. So I think it makes my job much easier. I wanted to start with a brief background as to why are we now moving into this energy efficient view. And a lot of it is not only cost driven for the mining operations to to save on costs, but there's also a lot of environmental benefits. And I think Marco Ann touched a lot on all the regulations that governs us now when it comes to carbon emissions and so on. So there's quite a lot of social responsibility when it comes to energy efficiency. And when we look at just how much energy is consumed in the mining industry, where we started off with approximately spending about 5% of our operational costs on energy, we now go all the way up to approximately 35% expenditure on energy in our operations. And this cost, it just keeps on increasing with all the volatility that we're seeing with Eskom and in our electricity supply in general. Just looking at our carbon emissions, we know that South Africa is the 12th largest greenhouse gas emitter in the world. We can see that we are actually even higher than China, and we're probably the worst sulfur polluter in the planet. And this calls for South Africa to take drastic steps in reducing our carbon emission and really looking at the trends currently in the industry, what companies are doing to create a more energy efficient mining operations. One of the solutions that the mining industry is looking into is the energy audits and monitoring. We are seeing a lot of technology that gets implemented that assists the mining operation in measuring the energy spends. A lot of resources goes into tracking our energy spends and monitoring where we are losing these energies. And renewable energy integration, we're looking there at our solar energies and wind energy integration, ensuring that we integrate the different sources of energy and not only relying on our energy grid, but also considering the integration of solar and wind energy and so on. We've seen a couple of the mining houses going into building wind farms and really going out to build solar powered power stations, and we've seen the impact that has been on those mining houses. Energy efficient equipment. I think Margo Ann touched on the hydrogen truck that was implemented at Mogalakwena, but also sort of moving away from equipment that are heavy consumption equipment when it comes to energy, and more moving into equipment that is energy efficient, as well as implementing new systems that is more energy efficient than the ones that we previously used. Just looking at heat recovery and cogeneration, especially in our hard rock operations, there's a lot of heat generation, and there's opportunity to recover the heat and co-generate heat so that we can generate our own energy in the same process that we are utilizing that energy. Optimized mine planning. So this is looking at the current mining that we are doing, planning it such that we have shorter hauls to reduce our energy spend, mining closer to our shafts, so that we spend less on transport and the energy to transport equipment and people underground. That all falls under optimized mine planning. planning the mine such that we absolutely optimize our energy spend. Advanced ventilation systems. Here we're looking at our underground mines where they utilize heavy energy dependent ventilation systems. There's opportunity also there to look into new technologies that are more advanced and can assist with optimizing our ventilation system to utilize less energy. Okay, just looking at waste and heat utilization. Just that is mostly on our implementing technologies that utilizes waste heat from mining operations to generate electricity. Yes, so utilizing our waste, basically greenhouse waste, to generate electricity. Energy efficient water management. We know that water is also a generator of electricity. Utilizing the water that we do have, the water systems that we do have to generate electricity for us on our operations. That's also one of the energy efficient systems that we could implement in our operation. And Yaku touched a lot on employee awareness and training, the importance of bringing the employees along on the journey when it comes to energy efficiency. Operators knowing what their role is when it comes to saving energy, as well as just switching off when they're supposed to switch off, when they're not utilizing the machine productively, but to switch off. So it's important to take our employees along on the journey and show them the advantages of our energy saving initiatives. Advanced data analysis, the importance of having data that we can trust. Yaku also touched on a lot on data-driven solutions, having data that we can trust that will guide us in making the right decisions when it comes to our energy spends. Monitoring, we utilize that data then to monitor our spends and identify our opportunities in terms of where we can potentially reduce our consumption and where we can save on our energy spends. And the last one being automated systems and robotics. So instead of relying on the human to switch off when they're supposed to switch off, we could implement automated systems that will identify that this machine is not required to run and automatically switch it off, or implement robotics that will be able to identify opportunities and switch off when they're supposed to switch off. And as I said, I was going to be quite brief. I just looked at different companies that are really doing great when it comes to energy efficiency, and one of the companies is Gold Fields. We have switched to solar power, partially switched to solar power. South Deep's Khanyisa solar plant consists of 100,000 solar panels, and they have done a huge capital investment there to generate power that will account for approximately 24% of their annual electricity consumption. Pan Africa Resources also commissioned a solar plant, and they produce around 10 megawatts of renewable energy at their Evander mine in Mpumalanga. The company has also taken steps to expand their plant to 21 or approximately 22 megawatts, and still has plans to further expand their solar generating capacity then. Harmony has also implemented solar panels with a solar plant of approximately 30 megawatts. So these are just some of the companies that have taken the renewable energy route to decrease their reliance on South African power grid. And Maria, that is me. Thank you.
Thank you, Betty. You certainly did not joke when you said you're going to keep it short and sweet. Yeah. So for me, as I said, I love data, and I work a lot with data, and I find that there is this one golden string that's been tying through all three. It's actually quite a couple of for me themes. It's like know the process, bring the people along, know your data and trust your data, and then implement it in such a way. So when you look at the Just Energy Transition plan that's currently the JET IT that Marga was also referring to, do you feel that one it's attainable, and do you think it's something that's really worthwhile working to? And if so, why?
I do think it's attainable, and there are companies that are really working towards the just energy transition, and it takes individual companies making that decision to work towards the renewable energy and work towards reducing their reliance on our power grid. So it does take individual companies making that commitment and actually sticking to it. So I do think that it is attainable.
Yes, because especially from my side, when you think about it, you are quite heavily invested in coal mining, being at Thungela, but I don't think it's going to be a quick one-step transition. There's always going to be coal in the background, but certainly looking forward and looking at future technologies to supplement and then eventually surpass this is necessary. And then just one more question from my side. It's got probably, so it's just something that I'm wondering about. How do you think, if you don't want to answer, it's perfectly fine, but how do you think this, to look at more energy sufficient solutions in mining and associated industries, and with the eye on the just transition and energy, what do you think would be like one or two of the main influences that this will have in terms of women in mining or women in associated social structures around mining networks, if any?
I do think it will definitely benefit women in mining. For an example, and when we look at automated systems and robotics, which takes away the man and the human element and physically having to do tasks, which will benefit the women in mining, and also just looking at the way the systems that we implement to assist us in tracking our energy spends in implementing solutions. It's all opportunities for women to get involved in and in as an individual, businesses, creating business opportunities for our society. So all these changes that we are implementing in our transition phase, it all presents opportunity for our communities and social responsibilities, to take them along on the journey as well.
Perfect, thank you. Do we have any other questions or comments from anyone else in the room? Feel free to come off mute if you have something to say or add. Okay, so in this case, I would like to thank 𝗣𝗶𝘁𝘆 and Margot Ann Vanner, and as you too, 𝗏𝗶𝘁𝘁, for spending some time with us this evening to discuss how we can look at energy efficient solutions going forward in a mining context. Margot, I would dearly love to listen a bit more to what you started to touch on. I think that might be a whole session on itself, because when we look at policy and the rate at which policy moves, I think there is quite a lot of scope for innovation, as well as opportunity for growth, especially for women in mining as well. So thank you all for taking the time to join us this evening, and please reach out to us on our social platforms if you have any additional questions or comments for this session, and thank you for spending Thursday evening with us. Have a good evening. If you're traveling safe. If you're getting into load shedding, go and switch on that kettle now. Okay, have a good evening, and we're looking forward to hosting you for our next Tech Talk. Keep an eye on our socials. Thank you, and have a good evening.
Thank you so much, Miriam.